Alright, so today we're going to talk about a projectile motion. So have a look at this diagram here. Imagine if you throw something into the air. Just because of the gravity, the object is going to eventually come back to the ground. Alright? This is the diagram that represents this information here. Now this diagram, as you can see, the vertical axis is the vertical change in distance, and the horizontal axis could be both, could be either the x, distance, which is the horizontal distance, or the time, okay, the change in times. All right, for the projectile motion, in this course, a projectile is unaffected by the air resistance. This is not a physics, okay, lessons. So it's just a math, okay, and we don't talk about air resistance, and does not have a motor, all right. There is no external, external forces that applies to the objects, okay, apart from the gravitational force, the downwards force of gravity. All right. Okay, because this acceleration is downwards, all right, so it affects the vertical component of the velocity, according to the, the y double dash is equal to minus g. So what I want to do is I want to derive 6 equations. 6 equations, very important for you to solve any projectile motion question. So let's start with the first equation here. And those 6 equations are derived from integration. Okay, so let's start with those. Now, firstly, at every single point on the path, there is only one force that's acting on it. And that force is the downward gravity. Right, there's one downward gravity here. Alright, so because this acceleration is downward, so that's why we treat this as negative g. Okay, g is the gravitational constant. Alright, now we are going to break this one down into 2 components, the vertical and horizontal component. So this motion can be broken down into 2 components, the horizontal motion, and then vertical motion. Alright, and every single time when you're solving a projectile motion question, you do need to derive these 6 equations so you can actually solve the projectile motion question more effectively. Alright, now remember this is not a physics, so please do not use the physics formula to solve the projectile motion in mathematics. We're going to use the math formula to do it. However, the physics formula is actually derived from the mathematical formula. Alright, okay, so let's start with this. Alright, let's start with the horizontal component first, or the horizontal motion. Alright, so the first equation is horizontally, there is no acceleration, okay? So therefore, there is no horizontal, forces that applies to the object. So therefore, x double dot, or the horizontal acceleration, is equal to 0. Now, this is the equation number 1, which is quite useless at this stage, right? Quite useless. Equation number 1, that's the first equation. Now, equation number 2 is the x dot, the horizontal velocity. How do we find the horizontal velocity? Well, we need to integrate. So the horizontal velocity is equal to integrate the horizontal acceleration with respect to t, sorry, made a mistake. So integrate with respect to t. Alright, so then that gives you x dot is equal to integrate 0 dt, and then x dot is equal to c, because 0 is a constant number, and when you integrate a constant number, it's just equal to c. All right. Let's just put this as 1. Okay. All right. So x dot is equal to c1. Now, what's c1? The constant number 1. But what is c1? It is the horizontal component of the velocity. So how do we find the horizontal component of the velocity? So let's just draw a little diagram here. So imagine you have a projectile motion going this direction. All right. At this initial point, if I just draw a tangent line, that would be the initial velocity, which let's just call that's u. That's the initial velocity. Okay. Now, this initial velocity can be broken down into 2 components: the horizontal component and the vertical component, like what we did, like in the what's that called, the vector topic. this component or this initial velocity can be broken down, can be projected onto the horizontal or vertical axis. All right, so horizontally it's going this way, to the right. Okay, and we call that x dot because that's the horizontal velocity. Okay, and then vertically we can break this one down into the one that goes upwards, and we can call that y dot. And the most important thing is we need to know the angle. So angle in between is theta. Alright, so for majority of the questions, they will give you all this piece of information. They will give you the angle of projection. They will tell you what is the what's the initial velocity, all those information. So once you know that, then you should be able to derive the formula quite easily now. Alright, so how do we find C1? C1 is the initial horizontal velocity, which is the x dot. So how do we get to the x dot? Well, we're going to use the trigonometry. X dot is equal to u cos theta. We can use trigonometry to work out what is the x dot, which is quite easy. All right, and that's C1 because C1, remember, is the initial horizontal velocity here. All right, so now from here we can further derive the formula. So x dot is u cos theta. All right, so that's an equation number 2. Okay, that's an equation number 2. Now, the equation number 3 is the the horizontal displacement x. So how do we find the horizontal displacement? Well, we need to integrate again. So we need to integrate the horizontal velocity with respect to the time. So x is equal to integrate u cos theta dt. Now, please remember u cos theta, they are just constant number because, well, come on. U is a constant number here. You know what's the initial velocity, and theta is just the angle of projection. That's a constant number as well. So u cos theta is not a prenumeral, it's a constant. So when you integrate that, x is equal to ut cos theta. All right? And of course, we have to plus C2 at the end. Now, with that C2, it's pretty easy to work out what is C2. Now, when time equals to 0, there is no change in horizontal displacement because the starting point is the origin. Okay, so x equals 0. So when you do a substitution, you will get 0 equals to 0 plus C2. So that gives you C2 is equal to 0, which means x is equal to ut cos theta. So that's equation number 3. So we just finished the 3 equations horizontally. These are the horizontal motion. Okay, we finished the 3 equations. All right, now let's move on to the vertical motion. All right, and I'm just going to do the vertical motion on this side. So the vertical component of the motion, right? The first thing is we're starting from the y double dot again. What is y double dot? It is the vertical change in velocity, right? Change in velocity, acceleration. And then we know that the vertical change in acceleration is the gravity. So y double dot is minus g. This is something that you need to remember. Okay, even you don't do physics, you need to remember this. Y double dot is minus g. G is 9.8. Unless if the question says g is equal to 10 for easy calculation. Otherwise, your assumption is g is 9.8 in mathematics, okay? Don't do 9.82 unless, again, the question tells you. Otherwise, 9.8. All right, so that's equation number 4. From this equation, what we can do is we can, of course, we can integrate to obtain the vertical component of the velocity like we did previously. So I'm going to quickly do that. Negative g dt. So y dot is negative gt plus c3. Okay, so how do we find c3? Well, c3 is the vertical component of the velocity, which in this case, y dot. Okay, let's write this one down using different color. Y dot is u sine theta. Okay, u sine theta. So that tells you that when t equals to 0, y dot is u sine theta. When t equals to 0 means initially, right? Initially, the vertical component of the velocity is u sine theta. All right, and then when you do a substitution, you'll get c3 is u sine theta. So that gives you y dot is negative gt plus u sine theta. Okay, this is equation number 5. Very important equation. We're going to use that equation to do quite a lot of different, calculations. Okay, so that left us with one more equation to do, which is the vertical component of the displacement, which is y. Now we need to integrate this one more time with respect to t. So once we integrate this, that becomes negative. How do we do that? Okay, negative half gt squared, because remember you are integrating with respect to t, not with respect to g. G is the constant number, 9.8. All right, plus ut sine theta plus c4. Okay, all right, now this is a bit tricky this time for the c4. At this stage, c4 is equal to 0 because c4 is the starting point, the vertical displacement of the starting point. Okay, so I'm just going to leave that c4 there without finding this one out. Okay, depends on the cases. All right, so what does that mean? Let me just draw two different diagrams for you so you will understand what does that mean here. So if we have case 1 type of diagram, so the starting point or the starting point of a projection is on the ground, and then the finishing point is also on the ground, right? That's case number 1. So that's pretty easy. With that case here, then c4 is actually equals to 0. All right, because there is no change in vertical displacement. Y is equal to 0 when t equal to 0. However, with case number 2, we can have a projectile motion question when you are project something into the air from a top of the building, on a cliff, or somewhere. All right, somewhere when the starting point or the vertical change in the vertical distance is not equal to 0. So you are standing at this point here, and you're going to throw something, all right, into the air. So in that case, c4 becomes the height. Okay, the height here. Well, depends on question. All right. So these are the two cases of projectile motion question there. Of course, we do have more cases, but C4 is not sort of like relevant to other cases. All right. So C4 is equal to 0 if the starting point is on the ground. C4 is equal to the h if the starting point is on top of something, all right, on top of a building, on top of a mountain, or whatever. Okay, so now you have 6 formulas. All right, those 6 formulas, you need to use them to solve questions. All right. Now, once you know these 6 formulas, it's not enough. All right, we just know 6 formulas. So what? We need to use those 6 formulas to do the calculation, to do the questions. All right, and then there are 3 very important concepts that you need to know. All right, when using these 6 equations. And then next lesson, I will teach you how to do some questions related to these 6 equations. All right, so let's move on to the next part. All right, so now what I'm going to do is I'm going to just use the first case question. All right, so C4 is equal to 0. And then I'm going to write down the 6 equations right in the beginning. And then so we can use those 6 equations to do the calculation. Honestly, I memorized these 6 equations. It's pretty easy, so you don't have to derive it every single time. You can just write it straight away. Okay, so u cos theta, x is equal to ut cos theta. All right, y double dot is minus g, y dot is minus gt plus u sine theta, and y is equal to negative half gt squared plus ut sine theta. All right, so these are the 6 equations. Now, from these 6 equations, what we can do is we can derive 3 important concepts. All right, the first one is called the maximum height. Okay, the maximum height. And then the next one is the time of flight. And then the last one is the range, or the horizontal range. All right, so how do we find all these 3 pieces of information? Now remember today, for this one here, I'm using the first case, the standard one, all right, you're throwing something on the ground, and then the finishing point is also on the ground as well. All right, so what is the maximum height? What is the maximum height? Well, the maximum height is the distance here. So how high the object can reach. Okay, that is the maximum height. All right, then what is time of flight? Well, time of flight is the total time it takes, all right, to go from the starting point to the finishing point. That is the total time of flight. All right, and then lastly, what is the range? Well, range is the horizontal distance, which is the distance here as well. All right, although we're using the time, but remember we can replace the time by the x. They're representing the same idea. All right, so the total range or the total horizontal distance. All right, so our job is to work out all three information there. So how do we do that? Well, firstly, we are going to use the calculus, right? Maximum height means the first derivative, okay, of the vertical distance is equal to 0. All right, so at this point here, y dot equals to 0. Now, you can talk about it you can try to explain this using math or using physics. If you try to use physics to explain that, why the vertical velocity is equal to 0, is just because at the maximum height, the object is not moving. That's the turning point. The object is not moving. It's not moving up. It's not moving downwards. It's stopped at that point because of the gravity, right? Because previously it's moving up, right? Until a point where the gravity sort of kicks in, and then the upward forces are decreasing to the point where there is no motion upward. All right, and then the particle completely stop at that point. So y dot is equal to 0. If you try to use mathematics to explain that, it's quite easy. Maximum height, maximum means the greatest turning point. So first derivative is equal to 0. All right, so let's find the maximum height. We're going to let y dot equal to 0 to find the maximum height. So negative gt plus u sine theta is equal to 0. We're going to work out what is the time, so how long it takes for the particle to reach the maximum height. So t is equal to u sine theta over g. Okay, that's how you find the maximum height. That's the time it takes to reach the maximum height. Now, once you finish that, we need to find the maximum height. Then what we need to do is we are going to sub t equals to u sine theta over g into the y equation, okay? Into the vertical displacement equation to work out how high it goes, right? So y is equal to half gt squared. Yes, we're going to square that. It's going to be a bit crazy with the calculation, and u sine and then times by t. Okay, now we need to simplify this. That becomes negative half g times by u squared sine squared theta over g squared plus u squared sine squared theta over g. Right, to simplify this, g and g squared, the power of 2 cancels out. So y is equal to u squared sine squared theta over 2g, that's a minus, plus u squared sine squared theta over g. Okay, making the same denominator, times by 2, times by 2. Combine them together, that gives you u squared sine squared theta over 2g. That is the maximum height. You don't need to memorize the formula here, not this formula, because every single time you need to derive it. And that's how you derive it. What I suggest you to do is use this 6 equation, derive these 3 concepts, these 3 important information there yourself without looking at it, and then you compare my answers to see if you can get to that point. Very important. Make sure you do that. All right, that's the maximum height. Now, we need to find out the time of flight. So how long it takes for the object to reach the final destination, right? So time of flight. All right, so for the time of flight, okay, so I'll do two different ways. I will show you which one is easier and why I'm going to choose the harder method to find out the time of flight, okay? So time of flight, how do we do it? Well, what we need to do is we let y equals to 0. We let the vertical displacement equal to 0 because the object is here, if you pay attention to the diagram, okay? There is no change in vertical distance, right? The vertical displacement equals to 0, all right? It's underground, okay? So I want to work out how long it takes for y becomes 0 again. That's the idea, okay? All right, so time of flight, we're going to let y equals to 0. What's the y equation? All right, so let's just write in the y equation, -half gt squared plus ut sine theta. Okay, I told you I remember those formulas, so it's much easier to do the calculation. Right, how do we solve this equation? Okay. Well, firstly, you need to understand which one I'm solving. All right, am I solving for g, am I solving for u, or for theta, or for t? Okay, you're finding the time, so you're solving for t. So take the t outside, like factorize it. All right, so t equals to 0 for the first one, and the next one is that factor equals to 0. Okay, so -half gt is minus u sine theta, so t is equal to 2u sine theta over g. All right, 2u sine theta over g. So, very interesting. That's the time of flight. That's how long it takes, all right, for the particle to reach the ground again. Obviously, the first answer here is when t equals to 0, all right? That's the starting point. Now, I do have another way to offer you to do this time of flight question, but you have to remember there are some restrictions. What's the second method? Well, have a look at the previous answer we got, okay? Previous answer. Where is my previous answer? Here. That previous answer. What is this? That's the time for the particle to reach the maximum. Okay, so have a look. That is the time for the particle to reach the maximum. And have a look at this diagram. It's a parabola. It is a symmetrical diagram, all right? If I already know the time it takes to reach this point, and it's a symmetrical diagram, so can we just simply times by the time, okay, by 2? All right, because it's a symmetrical diagram. Right now, the maximum height it happens when t equals to the midpoint, okay, between the 0 time and the time it takes to reach the ground again. So we just simply times by 2. Okay, so let's have a look. If we times this by 2, so we have the t equals to u sine theta over g, and we multiply this number by 2, we get 2u sine theta over g. That is the time. All right, now let's compare the time here with the time there. Are they the same? Yep, they are the same thing. All right, so as you can see, method 2 is much easier, but the problem with that is obviously you have to find out the time it takes to reach the maximum height first, and then times by 2. But is there any restriction using this method to find the time of flight? Well, yes. This method only applies to the first case projectile motion question, where you can see there's a symmetrical diagram. It does not apply to the projectile motion question where you throw something on top of a building. All right, because this diagram here, that is the maximum height, and that's the time it takes. However, this is not a symmetrical diagram because the starting point is here. It is not a symmetrical diagram. If we draw a vertical and a horizontal axis, you can see this is not a symmetrical diagram. So this method is not going to work. You still need to let y equals to 0 to find the time of flight. Okay? All right, so we're going to move on to the next one. The next one is the range. How do we find the range? All right, so to find the range, it's really easy. Range is the x. So we write on x coordinate. All right, x is equal to ut cos theta. And as you can see, what we're missing here is the time it takes. But we know that time is the time of flight. How long it takes for the particle to travel, right? And then if we know what's the time of flight, and in this case, the time of flight is what? T is equal to 2u sine theta over g. Let me just double check if that's correct. 2u sine theta over g, yes. All right, so now what we need to do is just simply do a substitution. So we've got u cos theta times by 2u sine theta over g. All right, so x is equal to 2u square sine theta cos theta over g. Now, I don't really like this expression, so what we need to do is pay attention to here. That's 2, that's sine theta, that's cos theta. What does that become? That's a double angle formula. So it becomes u square sine 2 theta over g. All right, and then that is our last formula. You don't need to memorize this formula every single time again, you need to derive it. Okay, now from this range formula, there's one very important piece of information I would like to talk about because you probably is going to encounter those questions in exams later on. All right, so imagine we have a projectile motion that goes this direction here. All right, sometimes they do ask you a question like, all right, remember this time we don't talk about any air resistance, no air resistance, nothing at all, just perfect projectile motion. Okay, some question they will ask you, what is the angle, what is the best angle, all right, if we don't change the initial velocity, what is the best angle when you project something? So the range is going to be the maximum, okay? So we are going to have the maximum range. What is the angle? All right, because when we change the angle, think about it, all right? When we change the angle, sometimes the projectile looks like this, other times it looks like that, and then it looks like this probably. So it does depend on the angle and the initial speed. So the question is, if we don't change the initial speed, what is the best angle, right? Now, if you guess, I'm pretty sure sometimes people can just guess, right? The best angle is 45 degrees, right in the middle. All right, that's good. Yes, it is 45 degrees, pi on 4. But why? Okay, why is 45 degrees? Again, remember we don't talk about air resistance. When we add in, air resistance, then it's not 45 degrees anymore because the formula is different. All right, now please have a look at this range formula here. The range formula is u squared sine 2 theta over g. Now I want you to think about or pay attention to that sine 2 theta. Sine 2 theta. What is the maximum value for sine 2 theta? The maximum value of sine 2 theta is 1. Alright, it's equal to 1. That is the maximum value. Alright, so what does that mean? That means if we let sine 2 theta equals to 1, then 2 theta is equal to sine inverse 1. Alright, then 2 theta is 90 degrees. So what theta equals to? Well, 45. That is the reason. Any angle that's not equal to 45, you will be expecting to see that sine 2 theta is not going to be 1. It will be always less than 1. And therefore you are not going to get the maximum range. Okay? Excuse me, sorry. All right, so that's all I want to talk about in this lesson. All right, in the next video, what I would like to do is to show you how to do a few questions using the method we just learned today. But the most important thing I wanted to remember here is the 6 equations. Try to memorize those 6 equations, or at least try to memorize x double dot is equal to 0, y double dot is equal to negative g, because from there you can derive the rest of the other equations. And once you know that, make sure you know how to find the maximum height, what is the process to find the time of flight, and then the last one is how do we find the range, and as well as what is the best angle or the angle of projection, what is the best angle so we can have the maximum range. Okay, yeah, I hope you enjoyed the lesson, and I will see you guys again in the next video. All right, thank you.